Hello everyone, welcome back to my YouTube channel. This is Apurva from Sri Venkateshwara College of Engineering, Bangalore. Today let us discuss about the Newton's forward and backward interpolations, which comes under mathematics. So let us start with the introduction. Newton's forward and backward interpolations are numerical methods used for approximating values of functions between known data points. These methods are based on the principles of polynomial interpolations, which involves fitting a polynomial curve to a set of data points. Newton's interpolations techniques are widely used in various fields such as engineering, physics, and computer sciences. So let's see the Newton's forward interpolations. Newton's forward interpolations is used to estimate the values of a function at a point behind the last known data point. It uses a forward difference table to calculate the coefficients of interpolating polynomial. The forward difference table is constructed by taking the differences of consecutive data points in the given data set. So the interpolating polynomial is given by the formula p of x is equals to f of x naught plus x minus x naught into f of x naught x1 plus x minus x naught into x minus x1 into f of x naught x1 x2, where the f of x naught x1 denotes the forward difference of order 1 and f of x naught x1 x2 denotes the forward difference of order 2, and so on. The values of the functions at a desired point can be calculated using the interpolating polynomial. So the next is Newton's backward interpolations. Newton's backward interpolations is used to estimate the value of a function at a point preceding the first known data type. Similar to the forward interpolations, the backward interpolations also uses a backward difference to calculate the coefficients of interpolating polynomial. The backward difference table is constructed by taking the differences of consecutive data points in the reverse order. So the interpolating polynomial for backward interpolation is given by the formula p of x is equals to f of xn plus x minus xn into f of xn x minus n plus x minus xn into x minus xn minus 1 into f of xn xn minus 1 xn minus 2, where the f of xn x minus n denotes the backward difference of order 1 and f of xn xn minus 1 and xn minus 2 denotes the backward difference of order 2, and so on. By using the interpolating polynomial, the values of the function at a desired point can be approximated. So let's see the advantages. Newton's interpolations methods are relatively simple to implement and understand. These techniques can provide accurate approximations of the function's value within the given data range. The Newton's interpolations methods can be used for both evenly and unevenly spaced data points. So the next is the limitations of it. Newton's interpolations techniques can become computationally expensive for large data sets due to the need to form the difference tables. These methods assume that the function being interpolated is well behaved and can be accurately represented by a polynomial. Extrapolation using Newton's interpolations method can be produce reliable results outside the range for known data points. So the next is applications. Newton's interpolation methods are commonly used in numerical analysis to solve problems involving interpolations approximations. These techniques find applications in fields such as physics, engineering, finance, computer graphics, and data analysis. Newton's interpolations method are particularly useful in situations where regular sampling of data is not possible or practical. So the next is example for Newton's forward interpolations. Let us consider an example where we have a set of data points like x comma f of x as follows. So the 0 comma 1, 1 comma 2, 2 comma 5 and 3 comma 10. Using Newton's forward interpolations, we can estimate the value of f of 2.5. By constructing the forward difference table and applying the interpolation polynomial formula, we can find the approximations. So the next is example for Newton's backward interpolations. Let us use the same set of data point as in the previous example. This time we want to estimate the value of f of 0.5. Using Newton's backward interpolations, by constructing the backward difference table and applying the interpolating polynomial formula, we can find the approximation. So the next is comparisons of Newton's forward and backward interpolation. Newton's forward interpolation is used when the estimation valued behind the last known data point, while the backward interpolation is used for the values preceding the first known data point. Both methods construct different tables but in different directions. The choice between forward and backward interpolations depends on the direction and approximation needed. So the summary of Newton's forward and backward interpolations. Newton's forward and backward interpolations are numerical methods used for approximating values and a function between known data points. This technique involves constructing differences tables using interpolating polynomial to estimate function values. Forward interpolation is used for values behind last known data points, while backward interpolation is used for values preceding the first known data point. So that's all. Thank you.